What is vitrification in thermodynamics? Imagine turning a liquid into a solid so quickly that it skips forming crystals and becomes a glassy, smooth material instead. That's what vitrification is all about. It's a process where a liquid cools so fast that it avoids crystallization and becomes a non-crystalline, amorphous solid. This happens when the cooling rate is high enough to bypass the usual crystal formation during freezing. Instead of regular ice crystals forming, the molecules are frozen in a disorganized, glass-like state. The key temperature here is called the glass transition temperature, which is the point where the material shifts from a soft, rubbery state to a rigid, glassy state. When a substance cools from a liquid, it normally forms a solid with a regular, repeating pattern of molecules called a crystal. But if cooling happens too quickly or under certain conditions, the molecules don't have time to arrange themselves into crystals. Instead, they become trapped in a disordered state, creating a glass. This transition isn't a sudden change like freezing but a gradual process where the material's viscosity increases sharply. The molecules slow down and stop moving freely, making the material rigid but without the ordered structure of a crystal. In thermodynamics, vitrification is interesting because it involves changes in physical properties like viscosity and heat capacity, but not in the typical way that crystal formation does. The glass transition temperature marks the boundary between a more liquid-like state and a rigid, glassy state. It's important in many fields, especially in preserving biological samples. Instead of forming damaging ice crystals, vitrification turns biological tissues into a glass-like form, keeping cells intact during freezing. In materials science, vitrification is used in making ceramics and polymers. During cooling or curing, the material becomes glassy, which makes it stronger and less permeable. For example, in ceramics, vitrification occurs when a glass phase forms during fairing, making the final product durable and resistant to water. In polymers, especially thermosetting plastics, vitrification happens when curing raises the glass transition temperature above the curing temperature, resulting in a solid that resists further changes. Practically, vitrification is used in cryopreservation to keep biological tissues safe from ice damage. It's also used in manufacturing glass and ceramics to control their strength and impermeability. Hazardous waste can be stabilized by embedding it in a vitrified glass matrix, which keeps it safe over time. So, in simple terms, vitrification is a way to turn liquids into glassy solids quickly, avoiding crystal formation, and it plays a big role in preserving, manufacturing, and stabilizing materials.